So, we have earlier looked into the basic philosophy and importance of high voltage testings for the equipment. This concerns the reliability. So, in any electrical system, if insulation system is intact, there should not be any failures. So, to achieve this, the insulation system and corresponding conductor configuration must be appropriately designed. So, the basic criteria being, under all envisaged over voltage conditions, there should be no insulation failure. That is important factor to be noted here. Under high voltage phenomena, under working stress must be below levels to assure long life. So, that is very important. The line which is designed, the insulation which is designed for working stresses must be below the levels, so that the life of insulation could sustain for a long period of time. So, all high voltage tests have above basic philosophy, and these yesterday we had tried to mention about high voltage tests are usually classified as type, routine and sample tests. So, the reliability of individual test objects, the quality and consistency of the material is to be done. So, high voltage or the reliability tests for the high voltage equipments include dielectric tests with direct voltages for DC equipment, dielectric tests with AC voltages which are used for AC voltage levels of EHV or UHV, dielectric stress with impulse voltage and impulse currents. So, impulse voltages could be lightning impulse or a switching impulse voltages, and impulse currents, this could be a lightning impulse currents which a dielectric could see in the field because of the lightning activity. Both voltage and lightning currents are normally seen and the insulator has to withstand both the voltage and the surge currents because of the lightning. So, these have to be tested in the laboratory. So, tests with combination of above. So, apart from individual tests, the combination of the tests have also been to be carried out, and as discussed, the capacitance and talent measurements and pollution tests are also essential for better and long life of any insulating equipments. So, these surges yesterday we tried to discuss. The surges are a lightning impulse, this is again a switching impulse, this is a chop type of waveform. These two curves are for the exponential impulse current. So, in lightning strikes, lightning over voltages of this nature are seen, that is 1.2 by 50 microseconds, 1.2 being the front time and 50 being the tail time. Switching surges because of opening and closing of circuit breakers, you see 250 by 2500, the nature of surges could be of this. In case lightning strikes, impulse currents are also to be faced by the equipment, particularly like the surge arresters or other equipments. There the exponential impulse current could be of this particular wave shape, where the front time could be 8 microseconds and tail time could be around 20 microseconds. So, 8 by 20 is typical impulse current waveform which an equipment like a surge arrestor or a lightning arrestor has to face. Apart from this, surges like the rectangular type of impulses are also been seen in the lightning strikes. This is known as a rectangular type of waveform where the magnitude could go and stabilize over a period of time and comes down. So, this may be for few hundreds or microseconds to milliseconds. So, this type of surges do appear in the field where the insulation material has to withstand. So, this is one arrangement for a typical circuit for the combined test. We were talking about combined tests, not only AC, DC particular tests. In some of the cases we do require the combination of tests which simulates the natural conditions. So, this test is for a circuit breaker, arrangement is made for a circuit breaker, where one side of the circuit breaker is connected to a AC transformer with the measuring equipment like oscilloscope and so on. The other side is the impulse generator where the impulse voltage generator is connected. So, the current the AC voltage is applied to the circuit breaker at its normal operating voltage or the specified voltage by the utility and the manufacturer of the rated equipment. At the instant the voltage will be applied, on that voltage superimposed of the lightning surges could be lightning impulse from the impulse generator is applied for known applications, so that the breaker performance is tested, where during the normal functioning connected with the AC voltages, in case there are surges or the impulses which are generated because of the lightning surges are applied, and the verification for the circuit breaker is monitored and checked, this could withstand in the service. So, various type tests as per the international standards are being specified for different equipments which are used in high voltage and extra and ultra high voltage range. So, some of the tests include power frequency tests, where these are operated at 50 hertz. The power frequency dry because for clean conditions, and wet, that is because of the rain which the equipment could see in the service. So, this dry and wet conditions have to be simulated in the laboratory, and the power frequency dry and withstand flashover, withstand test and flashover. So, what is the insulation withstand with normal conditions, when what is the withstand level for the wet conditions in case of the rain or the surface becoming wet, and what is that flashover, what is the ultimate insulation level of that equipment, that is known as a flashover across that equipment. So, these three, that is a dry, withstand and flashover tests are performed in case of power frequency. Second is radio interference voltage measurement. Why radio interference voltage measurement? We will discuss with the circuit. The corona test, which causes the visible discharges on the hardware or the corona control rings. This is a creates not only the power loss, but the insulation could break down over a period of time. So, corona test has to be carried out. Then power frequency voltage distribution. So, voltage distribution is generally carried out for the insulator string at EHV and ultra high voltage. The number of discs which are connected in cascade will be in case of 400 kV 23 to 25, in case of 765 it will be around 35 to 40 discs. So, where the distribution of potential across these insulator discs have to be taken care, else the insulators near the line end could feel more stress, and they are likely to see more stress and may not be able to sustain for a longer period of time. So, that is one of the reason where the power frequency voltage distribution tests are to be carried out for long insulator strings. That is the power frequency test. The second is the impulse. Impulse is surge test. So, impulse or surge test is again basically to see the withstand voltage level. So, for 220 kV what is the minimum impulse level which it has to withstand, the standards have prescribed the values. So, that values has to be withstood by the equipment when impulse of 10 application of both positive or negative or 5 applications, whatever the manufacturer and the utility prescribe as per the standards, the equipment should be able to withstand that number of applications. And again impulse flashover. So, if impulse withstand, what is the voltage level it withstand, when it could flash over, the healthiness of an insulation when further the voltage level go on increasing. So, when is likely the flashover of that estimation also is being to be done for the severe effect in case the higher the voltage are seen by the equipment, the flashover should not happen. So, but this would be give an estimation of how the insulation flashover and what is the level which could be compared with the withstand and the flashover. Then switching surge, this is again a switching surge withstand test. This is because of some of the tests which have a combination I was mentioning earlier. So, combination of the closing and opening of the circuit breakers with the AC which is in continuous. So, their combination tests and switching surge for various insulators and also for the lightning arresters have to be carried out. Then pollution tests again or a contamination test, this is very important above extra high voltage levels. So, the pollution or a contamination phenomena has to be simulated in the laboratory, and for the worst conditions the insulators have to be tested or the surge arresters have to be tested for pollution tests in the laboratory. So, what are the tests which are normally carried out on isolators and circuit breakers? So, the electrical tests conducted for isolator and circuit breakers are normally classified as dielectric or over voltage tests. Again, these dielectric or over voltage tests are of power frequency and impulse tests. The temperature rise test, this is monitored by applying the suitable voltage where the circuit breaker or an isolator has to be in service, and the rise in temperature is monitored over a specified period. Then short circuit test, how the performance of the isolator circuit breaker in case of short circuit, that amount of current is applied to the equipment and it is verified whether it could withstand the surge currents during the short circuit of the network which could be seen. Then radio interference tests, as like earlier for insulator strings, the corona tests. So, these are all again specified by the standard bodies. Tests on transformers, transformers have to be tested for the lightning surges, lightning impulse 1.2 by 50 waveforms, switching surges 250 by 2500 microseconds. Partial discharge test to check any voids inside the transformer where the discharges specified should not exceed prescribed value. So, partial discharge measurements have to be conducted for the transformer, and short circuit test in case of the short circuit happening outside, the current which the transformer sees should be able to withstand for a period of time. So, this again a short circuit test on each phase and the ground for the transformer is normally the secondary is shorted and they try to see what is the capability of the transformer it could withstand over a period of time. For the cables you have again power frequency withstand test, it is very important. Then dielectric power factor test, then impulse withstand like lightning impulse, a partial discharge as mentioned earlier, voids could be there during manufacture of the cables or because of some discharges which are insulation getting degraded over a period of time could start giving the discharges on the insulation, and these partial discharges could bring down the insulation level of the cable. So, this has to be tested. Then life expectancy, this how long the cable could be in service. So, there are again prescribed tests for this to estimate the life expectancy for the service. A suitable voltage and time with the acceleration factor is normally applied in the laboratories, and the life expectancy measurements are carried out. So, coming to the surge arresters or lightning arresters. So, surge arresters or lightning arresters are very important components in the transmission network. These surge arresters are the important components which protect the major equipments like the transformer, surge arrestor, circuit breakers, many of the substation equipment, and also divert the lightning surges to the ground. So, very important component in the transmission system. So, there for surge arresters in the earlier days gap type of arresters were being employed, where the blocks of the arrestor elements would be placed one above the other with a spark gap, which are known as gap type of arresters. Basically, these arresters were of silicon carbide. So, initially silicon carbide material were used for the gap type of arresters. The newer ones which are known as the gapless type of surge arresters. So, gapless type of surge arresters, the elements or the nonlinear elements which are being employed are of zinc oxide material. So, earlier silicon carbide was used where the gap type arrangement. So, basically silicon carbide or the zinc oxide are non-linear type of resistive elements which are being stacked one above the other. Zinc oxide has better characteristics in compared to silicon carbide. That is how the technology has been migrated to zinc oxide. So, the gap type of arresters following tests have to be carried out. There is a power frequency spark over test, how the spark over happens when the power frequency voltage and how long the current it will be able to sustain and how it could able to quench the arc. Impulse spark over is a power frequency. Front of wave, that is a 1.2 by 50 or the waveform which is being applied. When is that exactly getting spark, that is the front of wave has to spark. So, that voltage we have to apply and find out the values. Then residual voltage is nothing but when the lightning strikes on the system, the surge arresters become active and it tries to see that the voltage over voltages are diverted to the ground. During the conduction of the surge, because of the surge natural lightning happening, the conduction of currents which are of higher magnitude, the voltages developed which are of higher than the normal operating voltages have to be diverted to the ground. During that process of the current being diverted, the voltage which is developed across the resistive element or non-resistive element of the surge arrestor is known as the residual voltage. So, that residual voltage have to be measured or tested. So, high current impulse test, again lightning currents, you have waveforms of 8 by 20, 4 by 10 microseconds. So, 4 by 10 constitutes the high current impulse waveform. So, these high current waveforms have to be applied and monitored for the functioning of the surge arresters. Then long duration tests. So, long duration again it depends on the transmission type of model where the inductor and capacitors are placed, and a rectangular waveform which we have discussed. The rectangular waveform simulation is being done, and that rectangular waveform simulation over a period of time, say in terms of milliseconds with a certain magnitude has to be applied and the performance of the arrestor has to be checked. Then operating duty cycle test, again it is a combination of the operating cycle like in the field. Operating duty cycle involves the AC voltage which is continuously applied across the arrestor. Then impulse current for a particular voltage level, current level, the impulse current has to be applied along with the continuous operating AC cycle. So, the operating duty, the functioning of the arrestor is verified. Similarly, switching surge here again you have a impulse switching impulse which are generated and applied to the surge arrestor. Switching surges are basically of 30 by 60 microseconds. So, 30 being the front time and 60 microseconds being the tail time. So, switching surges are applied for the arrestor and they are verified. The next being the pollution test. So, similar to the insulators, the pollution tests are also being conducted for the arrestor blocks, arrestor prorated units or full arrestors. For gap type of arrestors, these are the tests which are being used. So, residual voltage as mentioned earlier, reference voltage measurements, we have to check how the arrestor for the normal voltage levels, the current which the arrestor sees or the delivers during the operation, the reference voltage which is applied and measured. Then high current test similar to the gap is long duration operating duty is applied. The thermal equivalency is one thing which is not available here. The thermal equivalency is done for the gapless arrestor because there is no gaps in between each resistive elements. So, the continuous flow of leakage current in the field will be there. It will be in terms of microamps, but the temperature could increase over a period of time. This temperature could heat up the discs and it could offer lesser resistance and where the current flow could be more. So, that is the reason where the thermal equivalency has to be established. That again is prescribed as to be carried out over a period of time, how this thermal equivalency performance of an arrestor. Then the pollution test. Pollution tests are similar to the method which is being followed for the insulator strings. The contamination of the solution and whether going in for spray method or dipping method. The IEC 507 very clearly mentions about the various pollution techniques to be adopted in the laboratory for testing insulator strings and surge arresters. So, now we have tried to see the basic information about various type tests, either which are being used at the industry or a manufacturing stage and also at the certification laboratories. So, this slide gives you the information for various voltage levels, how many insulator of different ratings are being normally employed. This is a very information which is essential. So, as the voltage level goes up, you can see for the system voltage of 66, you can see the insulators in the field 5 to 6 insulators are being used, and disc rating could be 45 kilonewtons is a mechanical strength. And in case of tension string, this is for suspension, normally 6 are employed, tension also 6. So, 5 to 6 are employed and the disc rating could be 70 kilonewtons in case of tension string. In case of suspension, it could be 45. Similarly, for 132 kV, 9 or 10 discs are employed of 70 kilonewton rating, and for tension 10 are employed of 120 kilonewton. So, the mechanical strength requirement in case of tension is slightly higher. So, the disc employed is higher. For 220 kilovolts, 14 to 15 are employed in case of suspension, and the mechanical strength could be of 70 kilonewtons or 90 kilonewtons. And for the tension strings for 220 kV, 15 numbers of insulators are used with 120 kilonewtons. For 400 kV, anywhere between 23 to 25 or 24 are used depending upon the actual requirement and the area where the insulator string is used in case of suspension. So, the rating, mechanical rating will be 120 kilonewtons, and for tension strings it could be 23 or 24 or sometimes 25 insulators of 160 kilonewtons. It has to carry more load in tension. So, for 800 kV or 765 kV depending upon the creepage of the insulators. So, we either use 40 insulators if in case of 120 kilonewton or 160 kilonewton, or 35 insulators of higher rating, that is 210 kilonewton or higher. So, this is how the numbers depending upon the creepage level are chosen. So, the disc rating again it could be, in case if it is a 40 it could be 120 kilonewton or 160, or if it is 35 numbers it could be 210 kilonewtons. Now, some of the places where higher mechanical load is required, so they further go for 320 kilonewtons or 420 kilonewtons. In that case, the number of insulators from 35 decreases to 29 or 30 numbers. So, either it could be 40, 35 or 29 to 30 depending upon the creepage and the mechanical strength of the insulators which are used. So, for tension, usually if it is 210 kilonewton, 35 are used. If it is 320 or 400 kilonewtons, the number gets reduced by 5 or 6. So, we come to the important test which we were earlier discussing about the radio interference test. Why this radio interference test is very important, very clearly specified in the IEC standard, International Electrotechnical Commission standard 60437. Very clearly it explains the importance of the radio interference measurements to be carried out for all the high voltage, extra high voltage and ultra high voltage equipments. As these signals or the discharges which are happening on the surface hardware, current control rings, this could travel and could create problems with the communication network. So very clearly the standard mentions the RIB measurements before it is being installed in the field have to be carried out anywhere between the frequency range of 0.5 megahertz to 2.5 megahertz. This is the radio frequency band where the discharges could create problems to the radio networks. So visible discharge or a corona, this is described in Indian Standard 731. So where how to conduct the experiment by making the entire laboratory, the ambient should be complete dark, the voltage is energized to the specified level of the equipment, and the discharges should be monitored on the equipment to be tested. So in case of wherever the voltage when you are increasing, the discharge inception starts, it will be noted as the inception of the corona discharges, and when the discharges dies out, that is known as the extinction value. So this is how the visible discharge experiments are carried out in the high voltage laboratory. This circuit shows the radio interference measurements. This is a bit similar to the partial discharge experimental setup. So you see the high voltage transformer. This CS represents the stray capacitance because of the transformer from the bushing to the ground. So this is the connector. You have a filter with a corona shield. The filter is again tuned to a certain frequency which has to be measured. You have a high voltage bus. The bus has which is shown as a T is the termination or high voltage bus what we have shown here. The high voltage connection should be enough to see that the discharges do not come the high from this conductor, so which should not be communicated to the radio noise meter. So it should be sufficient enough where the discharges should not be. Then test object could be circuit breaker, insulator string or any of these things. So it is connected between the high voltage bus and the ground. Then you have a coupling capacitor. Again the coupling capacitor, the requirements are we will be discussing about that. You have a coupling capacitor. This coupling capacitor offers a very high impedance during power frequency voltages, and at higher frequencies this will allow the discharges which are being to be measured, like the string which is under test or the equipment under test. The discharges which are being generated are communicated from this through the capacitor and through the measuring impedance. The measuring impedance we have two arms R1 and R2, and this signal is being communicated to the radio noise meter which could measure the radio noise in terms of decibels or in terms of microvolts. So this is the basic measuring circuit for RIV, and a similar arrangement is made for the corona, where in case of corona the entire laboratory is made dark and ambience that no ambient light is available. Then the voltage level is increased from a lower value to the inception of the discharges on the sample, and the extension also is noted. So this is how the visible discharge is being done. So what are the important components of the circuit which we have shown here? What is the importance and how the component should be tuned for the RIV test. So high voltage transformer must be capable of supplying current which is required by the test object, and the coupling capacitor, that is very important. Further, the transformer is expected to be noise free. So that is important. If the transformer starts giving or discharges or noise, this will be communicated to the test equipment, and further that would be mixed up with the signal which is measured. So this should not happen. It should be noise free basically. That is one of the reason where the filter is available in the circuit, where this filter will limit the noise which is being transmitted to the measuring circuit. Then second comes after the transformer is the low pass filter which is being tuned. The RIV measurements are conducted between as mentioned earlier frequencies between 0.5 to 2.5 megahertz. This is prescribed in the standards 437 as mentioned. This filter must be capable of being tuned to resonance at the frequency of measurement. So the high voltage we know that transformers have capacitance up to several hundred picofarads. In case the filter were absent, suppose some of the noise currents, that is the noise generated by this transformer, could be passed on to the test object, and this will flow to the transformer. The filter presence of this avoids the noise signals which are being communicated, that is very, very important. And high voltage bus conductor or terminators, where the T was mentioned in the circuit, the conductor should be smooth, there should be no scratches or no projections or no, so that itself should not be giving the discharges. That is one of the reason where the conductor should be smooth and the ends properly terminated. All the ends, connecting ends should be properly terminated. You cannot expose the ends here, and it should be where the discharges are likely to happen. So, these ends or termination points have to be properly enclosed with a suitable shieldings arrangement made. So, coupling capacitor should be having capacitance above 1000 pf. So, whatever the coupling capacitor which is operating at 1 megahertz or 2.5 megahertz for the measurement, the signals which are being generated at frequencies, it should offer a low impedance and the signal should be transmitted. The requirement is minimum, it should be having a 1000 picofarad value. It is normally 5 to 6 times of the test object. So, test object, if it is in case of insulator string, how many insulators are there in the for a 400 kV, there are 23 to 25 insulators. So, each insulator is typically around 40 to 60 pf each case, each insulator. So, the capacitance which is measured, the total capacitance of the insulator is taken into consideration, and 5 to 6 times of the capacitance of the test object should be the coupling capacitor value. That is an important point to be noted. Coupling capacitor, apart from presenting a low impedance path to high frequency as mentioned, it also presents high impedance at power frequency. So, any power frequency signals which are trying to come through the coupling capacitor will be blocked, because this offers a very high impedance for power frequency signal. So, it should only operate for the higher frequency, not at a power frequency. The measuring impedance which has been shown to different resistive elements, the standards recommend the value for instance should be around 300 ohms, because the surge impedance of the transmission line is around 300 ohms. That is the reason where the resistance or the impedance should be, the measuring impedance should be 300 ohms. But it is again the standards allow the measurements could be made anywhere between 30 ohms to 300 ohms, and a suitable correction has to be applied for making equivalent to 300 ohms. So, this is clearly mentioned in the IEC 60437 standard. The measuring equipment, the radio noise meter which is being used for the measurements has to be international standard as per the CISPR, CISPR is the international standard for radio signal measurements or communication measurements. So, it has to adhere to that particular requirement. The radio interference measuring unit should have various ranges for the frequencies in case if it is required, and various models are available to be measured, and here the options of measuring at peak, quasi peak, average, several of these things are prescribed to see that any changes or useful information could be obtained. So, the radio noise meter also to be of international standard requirement for the measurement. Okay, we will stop. So, thank you.